Okay, now let's actually run a complete simple linear regression analysis. This is actually a really interesting section. So a local university conducted a survey of more than 2,000 MBA alumni to explore the issue of work-life balance, which we call WLB score. Each participant received a score from 0 to 100, with lower scores indicating a higher imbalance between work and life. So obviously, the higher your number, the more balanced you are between work and life. A sample of the data is available below. Let X be the average number of hours worked per week, and Y be your work-life balance scale score for each MBA alumnus. Now investigate the link between these two variables by conducting a complete simple linear regression analysis of the data. And we're going to summarize our findings. So my X value are going to be the scores, and my Y value are going to be my work-life balance. So let me go to Excel and let me get these tables here. Okay, things that I'm going to figure out. First of all, because I had to find the least squares regression, rounded to 2 decimal places as needed, I'm actually going to use Excel for all of these. I want to have this calculated. So I'm going to do the sum of the squares of x, y. I'm going to do the sum of the squares of x, x. I'm going to do the sum of the squares of y, y. I'm going to be able to find my beta 1. I'm going to find my x bar, my x average, my y average. And based on that, I'm going to be able to find my beta 0. Because I need my beta 1 and my beta 0 for my equation. And then I'm going to also find my sum of the squares of my error. I'm going to find my S. Remember, we saw this yesterday on a previous section. The S was our standard error. Then I called another one, I called the S of my beta 1, which I call that one the standard error of the least square slope. And then we're going to be able to find our T value and our P value. And lastly, we're going to find our R square. Okay. I know it's a lot, but let me remind you guys of formula. So I'm going to sum of the squares of x, y. My formula was going to be sigma of x, y minus sigma of x times sigma of y divided by n. I'm going to alternate between blue and black. My sum of the squares of x is going to be sigma x or sigma x squared minus sigma x times sigma of x divided by n. Sum of the squares of y squared, or sum of the squares of y is going to be sigma y times y minus sigma of y times the sigma of y divided by n. My beta 1 is going to be the sum of the squares of x, y divided by sum of the squares of x, x. My average of the x's, or we call x bar, is basically sigma y, because I mean sigma x, because I add all my x's divided by n. How much data do we have? Y bar, or the average of the y's, I'm going to add all the y's, so sigma y divided by n. Now my beta 0 is going to be my y bar minus my beta 1 times x bar. sum of the squares of the error is going to be sum of the squares of y times y minus sum of the squares of x times y times beta 1. Now, my standard error, we started seeing this recently. My standard error, or S, is going to be the square root of SSE over the degrees of freedom, which is n minus 2. Now, SB1, that's basically the standard error of least squared slope. That one we do S divided by the square root, the sum of the squares of xx. And our t-score here is going to be beta 1 divided by S of B1. Okay. So our data, let me transfer our data to Excel. I already did my X and my Y values. So here, I like to label things. So here I'm gonna go X times X. Here I'm gonna go X times Y. And lastly, Y times Y. So here I go equals X times X. Here at the side, I'm gonna go equals X times Y. And then here I go equals Y times Y. I highlight them and then I click on the point and drag it. I like to double check on something. So I go here. Yeah, that is X times X. So that was good. At random point here. Yeah, that is X times Y. Good. And a random point here. Y times Y. Good. Okay, so I like to check. Here at the bottom, I'm going to do my sigmas, basically my sums. I'm going to go equals sum, open parentheses. I want to add all my x's, so I highlight all the x's, close parentheses. So there, added all the x's. I go here on this thing here, I erase this 0. So here's my sigma x, sigma y, sigma xx, sigma xy, sigma yy. And I'm gonna do the sum of the squares of xy. I go back and I tell it sum of the squares of xy. Don't autocorrect it. Have to go sum of the squares of xx, sum of the squares of y, my beta 1, and then I'm gonna do my x bar, my average of the x's, and then I'm also gonna do my y bar. And then here I'm gonna go my beta 0. I'm gonna find my sum of the squares of my error. I'm gonna find our standard error. And then this one I call it SB1. That's how I label it here. But it's the standard error for the least square slope. And then I'm also gonna find our t value here. And let me do also a p-value. We're gonna find all this stuff right here. And then my r squared. I'm gonna call rs for r squared. So I'll be able to have all the information that I need. Okay, good. My sum of the squares of xy equals, gave you the guys the formula, sigma x times y. So this one minus sigma of x times sigma of y divided by n. Okay, I have 15 values. So 15 then equals sum of the squares of x. So it's sigma x squared minus sigma of x times sigma of x divided by n, which is 15. Sum of the squares of y is sigma of y minus sigma of y times sigma of y, click on this again, divided by 15, right? Divided by n. My beta 1 is equal to the sum of the squares of xy divided by the sum of the squares of x. My x bar is equal to sum of x divided by n. So in this case, divided by 15. My y bar equals the sum of the y's divided by n. So in this case, divided by 15. My beta 0 equals is y bar minus beta 1 times x bar. My sum of the squares of the error that go equals sum of squares of y minus sum of the squares of xy times beta 1. Here for my standard error that goes square root, so equals sqrt, open parentheses, and I had to go SSE divided by 13. Right, there's 15, so n is 15, n minus 2 gives me 13. Good. My SB1 I go equals s divided by square root, so sqrt, open parentheses, my square root of ss, the sum of the squares of xx. My t value, I'm gonna go equals beta 1 divided by the SB1. My p-value, come back here to our notes. We have a lot of information here already. For my find my least regression equation, let me go here. Remember the way we write this, it's y is equal to beta 1, beta 0 plus beta 1 times x. We already have our beta 0 and beta 1, so I'm going to write this. I'm going to run it to 2 decimal places. So I'm going to say I have 86.87, because that was our beta 1 was, beta 0 was 86.87. My beta 1 was a negative 0.67. 0.67 times x. Okay. Now check the usefulness of the hypothesized model. Consider the following hypotheses. My null hypothesis is that my beta 1 is 0, so my slope is 0. And in my alternate hypothesis, my beta is not equal to 0. Because of this hypothesis, this is a two-tail rule. Okay, now determine the standard deviation, or S. We found that from our table. If we go for S, we're going to find that's 18.24. So let me write 18.24. We have that already. My t value, we found that already. Our t value is a negative 1.09. Now we're going to finish with our p-value and an r-square. Now for our p-value, so a reminder, I have to go equals t-dist for t-distribution, open parentheses. Now here, I had to put in my t-value as a absolute value of t. Now, how am I going to type this? I want the calculator to go absolute, so ABS, and then put my t in it. So I have to go t distribution absolute value of t, comma, my degrees of freedom, which in my case is 13, because we have 15 numbers, so 15 minus 2 is 13, comma, and then the tails. How many tails, which in my case is 2. 2 tails. There's a 2-tail distribution. So this is what I'm going to find out for my p-value. So let me go and type this in. I'm going to go equals TDIST for t distribution, open parentheses, and I'm going to go ABS, open parentheses, and my t, close parentheses. So basically absolute value of t, comma, my degrees of freedom, I said it was 13, comma, how many tails? I said 2, close parentheses. So my p-value rounded to 3 decimal places is going to be 0.295. 0.295. Keep in mind, I rounded to 3 decimal places. Now, what is the value for the coefficient or r squared? Now, I'll be honest with you guys. I'll be honest. This thing, the formula, I don't want to confuse you guys with many formulas. So let me come back here. I'm going to use technology. I'm going to highlight my X and my Y values. I'm going to insert this. I'm going to say points. I'm going to go on the trend line. I'm going to go here under more options. And I'm going to say display the R square. So there, you guys see it. I'm going to round it to 2 decimal places, 0.08. Now the formula, like I said, I don't want to get you guys confused for the R squared. So I'm going to use technology. I already had the points. So 0.08. .08. I'm using Excel for this last part.